Hey, we're really fortunate today to also have a couple of experts from this industry that I have had the pleasure to work with in the past, Steve Hauser and Leo Benitez. They're both going to join us, and we're going to probe into a lot of the topics that have been covered today, but also some of the trends that we're seeing in this industry under this kind of pace of energy transition that we're all talking about today. So I would like to ask both Steve and Leo to introduce themselves. And as you do, if you can please share your vision of this future of the power grid. Where do you see this going? And anything that you've heard from today that you want to add on to. So I'll start with you, Steve.
All right, thanks, Mike, and good morning, everyone. It sounds like I missed a pretty good conversation in the last session, so maybe we can figure out a way to follow up with James and others on that topic. Yeah, so my name's Steve Hauser. I'm the CEO of the Gridwise Alliance. I actually founded the Gridwise Alliance now 17 years ago. Time flies. And my history is really primarily with advanced energy technologies over a now four-decade career. A lot of that's focused in the utility industry. But about 20 years ago, I was talking with folks about how IT was changing other industries, and we started wondering, so what could IT systems do to change the energy system, and in particular, the electricity infrastructure? And out of that grew the Gridwise Alliance and a number of other efforts that are still ongoing. But it's really been a passion of mine to understand and to help motivate the industry to move towards these more advanced technologies and systems. And we've created a number of visions of what that future grid looks like. Over the years, we've published different reports. Sometimes it's fun to go back 10 years and see what we were saying 10 years ago. Generally, the way I talk about it now, and Mike knows this, is I talk about it as we're moving towards a highly networked, highly optimized, highly functional, and highly secure grid. And really, IT systems serve as a basis for doing all four of those things to the grid. And on top of those things, of course, are numerous, almost multitude of applications and use cases, if you will. I'll stop there and let Leo introduce himself.
Thank you, Steve. Mike, it's a pleasure to be here. My name is Leo Benitez. I'm the Managing Director for Energy and Utilities in Indra. For most of you probably don't know about Indra, so very quickly, we are a Spanish-based. I'm talking today from Spain, from Madrid, a Spanish-based technology company. We work in different sectors. Very, I would say maybe one differentiator we have from our competitors that we work a lot not only in the IT side but also on the OT side. Even if we come really from IT, as opposite to what Steve was saying, we were mainly coming from IT, seeing this trend about OT IT integration, and what I'm being Indra, very industrial company, would say. We work in defense, in transport, in other sectors. We definitely wanted to play a big role in that space. We acquired a couple of years ago Advanced Control Systems, which is an Atlanta-based SCADA DMS manufacturer in the US, which it was a very strategic acquisition for us, because ACS give us this OT side of the business where we were not that strong before. So everything around IT, OT integration, IoT, etc., is definitely a core strategy for us. How we see the future, I think the fundamental change that we see is that the things are moving from upstream to downstream. No, talking about power grids here. No, there will be a lot going on in the distribution grid. Everybody's talking about putting the customer in the center of the new model. That means that customer will start making choices. They will start putting their solar panels. They will start buying electric vehicles. They will start even installing storage at their premise. And all that, all those distributed energy resources, the grid operators will need to integrate them. So I think the fundamental change is that there will be a lot going on in the distribution grid, as opposite to what happened in the last years. And at the same time, there will be a lot of renewable generation, intermittent renewable generation getting in the grid. So all that creates or gives a complexity that wasn't there in the last year. So beyond digitalization, there are fundamental changes in the way grid operators will need to manage the grid. So, and I think that's the main change or the main vision we have for the future grids.
Yeah, and it is an exciting future. You're right. I think we led this webinar today by claiming the electric utility industry is the IT industry. And I think when I mentioned that, I was really mentioning that you know, it is the kind of the place to be. It's where digital transformation and innovation is happening, but also it being, you know, IT as well. And I know where this move to the future is pushing more compute to the edge to enable AI and machine learning. And that does, and we've heard it today from the panels as well, there's this convergence between OT and IT. While the grid in the past has been kind of the domain of the operational technology, but we do know that IT is getting more and more involved. So this would be to you, Leo. What do you see the primary differences between the current system today and the system of the future?
Yeah, I think well, there is one thing. No, when we talk to the people that build this industry, no, they always tell you, well, that thing about OT IT integration, we have been doing that for the last decades, no? What are you talking about connecting things? We've been connecting RTUs and IDs, etc., for so many years, no? So and it's true, right? So the power industry has been an industry that, you know, the connection with the machines, with the infrastructure, has been there for long, no? The point is, when you see what will happen in the next few years, how many new points of control points or things that you need to monitor will happen. You're talking about times thousands. So we are not talking about just, you know, adding a few points to the existing SCADA. You are talking about we need to connect all the DERs out there, prosumers, all the stuff, the electric vehicle recharging stations, etc., etc. So you cannot do that with the control systems we've been implementing for the last decades. That's a completely new technology. That doesn't mean that those two have to work independently. But what we need to do is expand what we've been doing so far, controlling the grid, but using new technology, specifically IoT. And IoT is not, you know, talking about industrial IoT. I'm not talking here about putting a sensor, bringing it up to the cloud and managing the data there. I mean, the power, in order to control the power grid, you still need real time. You have to react in real time. So you cannot do that simply moving the data to the cloud and waiting, even if it's a couple of seconds. Couple of seconds is enough to have an outage in the grid. So we definitely need to have computing capabilities in the edge, and I think that's key. But you need to build a good architecture. I mean, if you go now, of course, I know a little bit more about what's going on in Europe. You go to the secondary substation, you see there a lot of sensors with their own gateways. The gateways moving the data to the cloud, and it's that's not sustainable, right? You cannot have one sensor, one gateway to the cloud. I mean, you definitely need to orchestrate that. You need to virtualize. You need to have because the use cases that you have to build, you need all those sensors the information coming from all those sensors to be available for a power flow analysis algorithm, for an outage prediction algorithm, for whatever. So definitely IoT together with edge computing and this capability to orchestrate, to have a good architecture that can orchestrate what will happen in the edge of the grid is absolutely clear. And I think this is a a big differentiator from where we are right now in order to manage these future grids.
Yes. So I can a follow-on question to that. So I agree with you. This platform for compute is needed to evolve as the growth of renewables and intermittent loads as well grow. And I also agree with you with this kind of tiered compute approach where there's compute power at the edge to be able to manage real time at the edge, these optimized intermittent loads. And then there's also the need to backhaul some of that data, maybe not all of that data, because the cost of the new data, new sources of data, and backhauling it all is going to be expensive. So where do you see the connectivity technologies fitting into the edge compute technologies as well? So I'm thinking about things like broadband over power line that we're starting to see getting deployed in Europe. We're also, of course, seeing 5G getting more commercialized. So where do you see some of these new connectivity technologies fitting into that edge compute technology you just described?
Yeah, I see. Well, yeah, definitely everybody's looking into 5G, right? As a technology that will help with that, because definitely you will need to move information to the cloud. I'm not saying that there will be a lot that will stay in the edge, but there will be information that there is one case, for example, that it's not necessarily related to monitoring the grid, but we're definitely using the same architecture where we are together with a utility in Europe. We are developing. I think I talked to you about that last time I saw you in Madrid. We are already working on a pilot for a wildfire detection solution where we are putting some cameras on top of a pole, and we are having an artificial vision algorithm that is running in the edge. It's running already there. But of course, when you detect a smoke or no in a forest, you need to send a portion of the video and an alarm to the control center. So you need connectivity, but at the same time, it doesn't make sense that you send all the video to the cloud in order to be processed there. It will be very expensive, non-optimal, absolutely, to have that setup. So everybody definitely. Broadband, PLC, and 5G are definitely technologies that European utilities are looking into in order to be able to connect these gateways. Still with processing capability, but definitely we will need to be connected.
Yeah, and Steve, so after we go down this path, and who knows how long it's going to take to modernize the full grid.
Right.
It may take a long time, but what's the potential here? What is this new type of system that Leo is talking about? What's that going to enable going forward that maybe doesn't exist today?
Well, there's a couple things. I mean, you could probably come up with a list of 30 or 40, right? If we worked at it. But I'll go back to what I said a few minutes ago and focus in on highly optimized and highly functional. I think we're realizing now that we have this network of sensors and the software and the analytic tools to kind of monitor everything, we're realizing there's a lot more opportunity for efficiency gains than maybe we appreciated going into it. And some of that might be focused on end use, where you actually are identifying efficiency gains in the customer at the customer premise. But you're also identifying efficiency gains throughout the transmission and distribution system, whether that's different kinds of transformers or switches or relays or protection systems or whatever. You have the opportunity to kind of squeeze out efficiency for sure. And then the other one I'll emphasize is the functionality, which is kind of what Leo was talking about a little bit more, which is we're now entering a phase where we can provide functions, whether it's at the substation level or in the network somewhere, that provides the operators the ability to do different functions, whether it's real-time predictions of failures or outages, or whether it's restore and respond to events that are going on in the system, or whether it's just integrating the intermittent systems, electric vehicles, rooftop solar, wind, and so on, storage throughout the system. It's just, there's going to be a functionality that goes something like an order of magnitude more than what we've had historically.
And do you see, from your position at Gridwise Alliance, do you see utilities seeing the opportunity to use this new grid as a platform for delivering new services, or is it more that they partner with companies that are delivering new services? Where do you see that? I mean, again, this is new services, new revenue streams as well,
Sure.
maybe not traditional utility revenue streams. Where do you see that going?
Well, I think I mean, we had a session a couple of days ago around utility business models, and there was probably 40 or more utilities in the discussion. And I would say there's a whole spectrum, right? I mean, there are some utilities that are very much on point in looking at this as creating new services for them, and they're excited about that. And there's others that are probably taking a little more passive perspective and leaning much more on providers to give those services. So one of the questions I asked the group on earlier this week was, are we going to converge on one solution? Are we learning enough from all these different projects and changes going on that we're going to find 10 years from now that we've converged on a single solution? And it seemed like the answer was no. There's going to be a broad spectrum of both business models and operational solutions that will emerge based on the constraints or the context in which that particular utility operates. Mm-hmm. I will give one quick example. You brought up Fort Collins earlier, Mike, and Fort Collins years ago decided to underground their entire distribution system. You won't see wires anywhere in Fort Collins, and it's a city of nearly 200,000 people and a big university campus and so on. But it's all underground. Plus, we don't get storms like the Gulf Coast does, right, in Colorado. So they don't worry about reliability and resiliency so much. But if you go down to, utilities along the Gulf Coast or even on the Eastern Shore, reliability and resiliency is a huge factor in their planning and design of their system, and what kind of sensors are installed and so on. So that's the kind of context which will sort of push utilities in probably somewhat different directions over time.
Perfect, thank you. I'm going to go the other end of the spectrum, and this question is for Leo. So in those areas where that type of power grid is not built out, and I don't know too many places where power grids are completely underground. That's probably one of the more advanced applications of grid technology. But there are areas, excuse me, where there is no grid built out. And I'll go back to, in my example of the telecommunications industry. So in a lot of places, the traditional hardline telecommunication infrastructure was never built. And they jumped to cellular as the telecommunications backhaul and started building off of cellular technology and wireless multi-point systems. And I know, Leo, your company is working in areas where developing new power grids is bringing new services to areas, especially in the areas that you're working on in Africa and in the Middle East and Latin America. So what's your take on how this advanced power grid, or maybe it's more advanced microgrids, or it's a grid of microgrids? So how do you see this technology impacting those areas that are on the far reaches of the power grid?
Yeah, it's definitely having a major impact. Now we are seeing a lot of money coming to that, especially from multilateral institutions like the World Bank or African Development Bank or etc. Definitely, I don't see many funds associated to transmission lines. No, so I think everybody realized that it doesn't make sense
Mhm.
to build, to put a line and cross maybe a forest, and with all the environmental implications or impacts, when you have the possibility to have to source the electricity from there, either from the sun, from the wind, or from a small river that you have there, or whatever. No, so absolutely, I think the deployments of microgrids in all these areas is something that where there is a big expectation on the investment that will happen in there. And yeah, we are working on building the technology in order to be able for you to control such a microgrid. Now we have a very interesting case, definitely not in a third world country. I'm talking about Australia. No, the project we are doing in Monash University, but in the end it's the same technology. We're working together with Intel and some other partners in putting our solution in order to control the microgrid of a big campus that they have outside of Melbourne, where we are integrating different distributed energy resources, connecting to the building management systems of the different buildings they have there, and proving that the technology is there in order to control a highly, let's say, intensive microgrid. And the, I mean, really the results are really very interested. We are even putting a blockchain layer on top of that. That's a little bit sophisticated, but in order to prove that you can also have bilateral transactions between the different buildings, for example, of the campus. No, so that's the future. We found a very interesting place to test it. And we are, of course, downsizing that solution in order to be able to cope with these scenarios that you are asking me, Mike, that are more related to electrifying communities that they don't have power right now. So it's definitely a very interesting use case.
Thank you. I agree with you. And I'm going to give Steve a softball question. It seems maybe softball when I ask it, but I've been asked this myself before. So what Leo just described and what some of the panel members have talked about in terms of the move for a more modern grid. And you even mentioned it yourself, Steve, that, you know, in some of the utilities on the Gulf Coast and in other areas, I would even say on the West Coast, where natural disasters have a direct impact on the ability to deliver reliable energy. Is this new model more sustainable? And again, as I said, it seems like a softball question, but what are your thoughts? And if you agree it is, which I think you do, you know, why is this modern grid more sustainable?
Well, I could answer that in some different ways, but the one thing that comes to mind, based even what Leo was just saying, is that this system we're talking about, the future grid that allows much more functionality, much more accurate understanding of what's going on in the system, it's going to allow utilities or, you know, emerging companies like Indra that are doing things in Africa, it's going to allow them to differentiate customers in a way that we've never really done before, right? So, you know, we don't have to go back too long to think about utilities said, okay, we've got residential customers, we've got commercial customers, and we've got industrial customers, and they're just kind of all lumped together into one big bag. And now what we're understanding is that there are no, you know, common or typical customer, especially in the era of COVID that we're going through now, you know, where so many people are working from home. Homes become offices, homes become businesses, homes become medical centers with the medical equipment that has to be kept on much higher reliability. So I think what it allows the future to look like is the ability to differentiate customers based on service needs, and not just, you know, just electrons coming into a building and all electrons are created the same. I think electrons are going to have to be considered differently depending on what kind of use they're going to be used for. And I suspect the service models are going to emerge that allow utilities or service providers to charge different things for different services. It almost has to, right? So you mentioned the Gulf Coast. I mean, in regions where reliability can be an issue, particularly in certain times of the year, we're going to have to understand which customers are critical customers, right?
Mhm.
Which customers absolutely have to have electricity almost no matter what, 100% reliability, which I know is, maybe a stretch. But then there are customers that probably don't need to have that level of reliability, are willing to pay less for the electricity that they use because they don't need that kind of reliability. They're
Mhm.
still going to have the refrigerators working, after a few hours, or the food spoils, right? So
Mhm.
there's all sorts of issues that I think we have to work through in terms of what service reliability and what services are provided to customers going
Mhm.
forward.
Yeah, I agree that, getting that pulse on, real-time demand at the edge, I think is an important outcome of this. One of the really more interesting conversations I've had recently was with a technology provider yesterday in the UK, talking about frequency regulation. And normally when you talk about frequency regulation, it's around how do you manage intermittent loads at
Yeah.
the edge of the grid, which I know that's one of the big use cases coming out of this, grid modernization. But in this case, the use case was low demand driven by, COVID and the
Mhm.
significant lowering of demand, which was the opposite side of frequency regulation, and
Yeah.
using these technologies to be able to balance load when you start to get dips in demand. So again, new problem statements that we hadn't thought of before
Yeah, absolutely.
that I think are being driven by COVID. And one of the other things that I think I've seen, a lot of folks in the call have seen, is the aggressive entrance from the oil and gas space. And for those that are tracking that industry, you've seen the announcements from Shell and British Petroleum on their reduction in or their declaration of reduction of oil production. I think in some cases up to 40 to 50%, which is a massive shift in value, if you will, and moving that energy and money investment into clean renewable energy, which for me, I think we're going to see an even bigger push towards renewable energy and distributed loads on the edge. So I'll ask this question of Leo. Leo, you're in Europe. I think you're in Europe. You're a little more advanced in terms of the type of services that you're seeing being offered by these companies. Offering EV charging services, offering microgrids at the home and the business. So, have you thought about what the impacts of these oil and gas companies moving into this space will have in our industry?
Yep, and I would say they are already there. I can tell you that if you see Repsol, for example, in Spain, they acquire 500,000 customers from utility 3 years ago. They are now over 1.5 million. So you can see how aggressive they've been in the market in the last 2 years, offering new services and getting the customers from the traditional utilities in Spain. This is an example. Another example also from Spain is Total, the big French oil and gas company. They just acquired 2 million customers from EDP in Spain. So they will become the 4th largest utility in Spain. So everyone, Cepsa, Repsol, Total, BP, you name it, everyone is really, and they are, and as they don't have the wires, right? Because they typically don't buy the grid, the grid. They are really very aggressive. I mean, they come really with new services, with very aggressive prices also on the kilowatt hours. But more than the kilowatt hours and what Steve was saying, I think definitely, I think this sector is moving from selling kilowatt hours to selling services, right? So what we are going to sell our services, and we see everything. I mean, we see definitely distributed generation. You see electric vehicle. We are hoping that in 2-3 years they become I mean, the price will be similar to the traditional car. So there will be a boom also in the adoption of electric vehicles. We are working also, for example, with the consumer associations. We have a very recent project with a chain of supermarkets here in Europe as well, where we are trying to identify how they can monetize the flexibility they have on the demand side. And after the analysis we did, we saw that the project pays off in 2-3 years. And if you see 5 years, they really earn a lot of money. So there is a lot going on. I definitely think demand management, for example, in Europe will be a big thing in the next years. The European Commission is pushing all countries to adopt the demand management and to open the wholesale market for demand management. And we will see a lot of stuff. And in order to manage demand, you need to monitor the demand, and you need to put intelligence there also in order to do what Steve was mentioning about. Okay, you can change the load of this, but you cannot, for example, a supermarket, you can change the climate, the temperature of the building, but you cannot change where I'm storing the fruits or whatever. No, so I definitely see a lot that will happen, and in Europe in the next 2-3 years, especially around demand management, we will see a lot of things moving.
Perfect, thank you. I know we're going to run out of time in a minute. I could talk to you guys forever. I got a couple other quick questions, and one of these was asked to me recently in a blog I did, and that is, and I'll go with Steve on this one. You know, we have been today and talking about the future of energy, and this is a topic that I keep hearing more and more about, and it's really growing. As we said already, into the oil and gas industry and other spaces, including corporate sustainability. What is, in the future, what do you believe is tangible and real, and what we hear and talk about, and what's science fiction? So giving, examples like carbon capture,
small nuclear
fuel. So what are those things? And I know you're right there in the pulse of all this. What's real and what's tangible? And, what do you think is science fiction?
Well, it's so hard to predict that. I mean, I was asked a similar question not too long ago, and I said I'm old enough to remember when fusion was going to, be our choice of supply in the year 2000 and going forward, right? And it was all gonna be free, right? It was basically, so cheap that we'd have all the electricity we wanted, so obviously solar and wind are here to stay. Storage batteries are here to stay for sure. Electric vehicles are here to stay. So those are persistent. When you start talking about carbon capture, you start talking about small nuclear, you start talking about green hydrogen and other things. Those things, I hate to be a pessimist, but I think those are 2 decades and more off. I don't think we're going to see a big uptick in radical new technologies within the next 2 decades, maybe even 3 decades, 2050. But, technology is a funny thing. I mean, Apple iPhones are only 13 years old now, right? Or something. They're a relatively new technology. So, things could come on the market that we don't really expect, and there could be breakthroughs in some of those technologies that we can't predict right now. So who knows? Stay tuned.
So I'll ask a quick question of Leo. So we've talked about different players in this space. Obviously, utilities owning the distribution network are going to be a key player in this grid modernization and all the new services that get delivered off of it. But who do you believe is driving this future of the energy? Is it the oil and gas companies? Is it the new service providers? Is it governments? Is it the move towards clean renewable energy to drive the impacts of climate change, or I would say lower the impacts of climate change? Is it Wall Street? What's the big driver that you think is going to move us forward in this new future of energy?
Well, definitely in renewables, I think the oil and gas companies will have a major role. I'm seeing a lot of reports recently saying that the future of renewables, that the oil and gas companies will be the ones that will invest more in renewables. Talking about utility scale, typically, well, you need capital, and oil and gas companies know a lot about that, and once they know how to do it, I mean, they have the money to spend and to build that infrastructure. No, when you talk about the client, I see there will be a lot of players, no, and I mean, everybody says that in 2024 the price of a car, electric vehicle, will be the same as a combustion engine. So in 2025 it will be cheaper. So it will be the loss of the market. No, the customer will start buying electric vehicles. If you buy electric vehicles, you will need a recharger. If you need a recharger, that will affect the grid. You will need to monitor that point, etc., etc. Same with solar panels, same with everything. So as long as I mean, the regulator don't stop those things to happen, and they shouldn't, right? Things will happen naturally because the technology will be there, will be competitive. So the real driver behind the change will be the consumer, will be the citizens that will start consuming those the energy resources. And once they start to do that, so there will appear companies that will start making those offers. The grid operator will need to monitor those points, etc., etc. So on the renewable side, I see definitely oil and gas and big corporations. But when you talk about the customer side, the lower part of the grid, the downstream part of the grid, really the driving force will be the citizens, the people.
And you think those community mandates, state mandates on carbon are going to drive consumers and then hence drive the market?
Some of them, but I think in the end, you know, there are people that are more conscious about the environment and they are willing to pay a little bit more if it's green. But the way we are seeing the technology, it will be competitive in very soon. So even if you are not conscious about the environment, but if you are conscious about your money, you will start consuming those resources. And when you start doing that, it's unstoppable, right? Everybody, it's like the mobile phones. I mean, what Steve was mentioning before. Nobody, I mean, now smartphones are cheap, so people start consuming them. So why not consume these resources, these things that I mentioned?
Great, Leo. Thank you. I think we're about out of time. But before we go, I want to thank both of you. This has been a great session. Like I have in the past, really lean on both of you guys for your expertise and your partnership with Intel has been fantastic. So we look forward to working with you more in the future.
Absolutely. Thank you.
Thank you very much.
With that, thank you, Leo.